Hi all, this is Hamartaj from Department of Automobile Engineering, presently working at SJ Government Polytechnic. Today I am going to give you a presentation on the continuation of Unit 1, that is Session 3. Let us just go through the review of previous session. We have learned features of solid edge environment and geometric relationships in the last class. So what are the features of solid edge? In the features of solid edge, we have learned what do you mean by parametric design, process specific features, feature based mode. Then we have learned bidirectional associativity, and then also we have learned interoperability. Okay, so in these features, parametric design means the parameters of or the dimensions of a drawing can be changed anytime in the modeling. That is nothing but parametric design. Then if you come to features, a drawing will be divided into a number of features which will be very much useful. And then if you come to bidirectional associativity, that means you have done a drawing, and if you have done say for example anything in your draft modeling and you are in the part modeling, you have to change something in the part environment. If you change, it will automatically be changed in the draft environment, or in the assembly you have been already and you have to do any change in the part drawing, you can just go over there, change it, it will automatically be uploaded into the assembly drawing. Okay, like that. So interoperability in the sense, solid edge, this actually provides the transfer of data from other platforms. Say for example from ProE, if you have done any drawing in ProE and you have to transfer it, so then you can use any trustworthy tools to transfer the data from ProE into the solid edge. What it does is it will save lot of time, and it is very much effective as well. Okay. So next, that is about your features of solid edge. Next thing is solid edge environment. We have learned different kinds of environments: part environment, draft environment, assembly environment, weldment environment, sheet metal environment. In the part environment, we are doing the part drawing, part modeling. In draft environment, it gives you the detailing of the drawing. In assembly, we are calling the parts from the part modeling and assembling it. And then in your weldment, you can, after doing the drawings in the part modeling or part drawings or to the assembly drawings, you can give a welded, you can do the welding for the parts. Okay. Next, we learned geometric relationships. In the geometric relationships, we have learned many things like concentricity, in the sense to if either it's a circle or curve, if they are not having common centers, we can select those entities and then we can give a common center for them, or for the arc by selecting it. Say for example parallel, if two lines are not parallel, we can select them and do the parallel. By applying these geometric relationships, what happens is our drawing becomes precise or perfect. Okay, so and then any other thing, perpendicularity or symmetric, for that any matter, for example. Okay, so this is about the review for of the previous session. Let us move to today's session. Now, contents. Assembly relationships. And in the assembly relationships, what happens is we will be learning different kinds of relationships: assembly relationships, constraints, concept, need and types, parametric modeling software workbenches, concept, types, functions of each type. Now, Assembly relationships. The assembly relationships are the logical operations performed on the components to assemble them at their respective working position in an assembly. I told you in the assembly what we will do is from part modeling we will call the part drawings, and then we will apply any of the logical operations we will be performing or applying it onto the components to assemble them at their respective working position in an assembly. See, we are having some of the assembly relationships over here, that is mate, planar align, axial align, insert, connect, angle, tangent, cam. These are the things. So a few things I might tell you over here. Mate in the sense we are mating two parts. We are combining two parts, clubbing two parts. By clicking on this mate, you can just go ahead and any two, first part drawing you have called and the second one if you call, and then you are mating both of them. Means you are joining both of them. Likewise, if you planar align, one part modeling, you are selecting the plane of one part modeling and joining with the other plane of the other part drawing. So likewise you can do it. Axial align in the sense, so what you will do is first when you have to axially align something in the sense to the axis. So what we will do is we will select in one part, we will see what is the center of that particular part, means central axis, and then the other part also we will see the axis, and both the axis has to be matched with each other. Then what happens, the axial align will take place. Okay, likewise similarly the other things and all we will be learning in the upcoming sessions whenever you will be doing the assembly. Now let us come to entity. What is this entity? See, an element of geometry is called an entity. That is, an entity can be an arc, a line, a circle, a point, and so on. It might be arc. See, anything that you are selecting. In the CAD, you people have learned in the third semester, wherein you will choose arc, line, circle, point, anything, and you will be doing it in the drawing workbench. So that is nothing but your entity. Similarly, in the solid edge also we are having these entities. Okay, in the first session we have seen it also. Now the next one is profile and sketch. The sketch drawn using the sketch tool is called a sketch. By using any in the sketch tool will be at the top of the solid edge workbench. There when you select it, sketch tool, and then draw it, that is nothing but the sketch drawn using the sketch tool. Then sketch drawn using a feature creation tool is called a profile. When you draw a profile, say for example, see for the sketch tool, let me give you example. Sketch drawn, you are selecting sketch and you are drawing, taking line, arc, something and drawing it. And sketch drawn using a feature creation tool. Any features you are applying for that. Okay, feature you are giving it, then it will be called a profile. In the sense you will be applying extrusion command, or you will be applying a revolve command. All those things will be the feature. You are making that sketch now. Earlier it was only a sketch, now you are converting it into a profile. Prompt line. When you choose a tool, the prompt line is displayed below the ribbon bar. See, always this prompt line helps you in creating a model because it gives you the prompt sequences to use the tool. What next to be done? In the sense, when you choose a circle, then it will tell you, give the center point. Then when you select the center point, it will tell you, give the radius or radius or diameter. Whatever next thing you want to do, it will help you. So this is helpful while creating a model because it provides you with the prompt sequences to use to a tool. Now the next one is edge bar. When you choose the edge bar button from the main toolbar, the edge bar is removed from the main window. Means in the main toolbar you will be having edge bar. When you click on that, it will come out and it will be displayed. It lists all occurrences of features and sketches of a module in a chronicle, in the sense in order. Edge bar is a model tree window that highlights the operations performed on the active model. What are the operations that are performed on the active model? It will show you people. It helps you to manage and complete tasks on a design project. Click edge bar icon on the main menu to display the edge bar window. Let us see once you click what happens. See here, the edge bar window will come and this is how it looks. When you click on the edge bar comes out. It basically what it does is, as I told you, it's a model tree that highlights the operation performed on an active model. Okay. Now, the edge bar window contains different tabs and offers different functionality. The edge bar is environment specific and the tabs vary according to the environment. In the sense, when you are in the draft environment, the edge bar behaves differently. If you are in the part environment, it is different, and for the assembly environment also. For example, in the part environment, we can notice the following tabs. When you get the, click on the edge bar in the part environment, you will be getting all these things. First one is Feature Path Finder tab, Feature Library tab, Family of Parts tab, Layers tab, Sensors tab, and Feature Playback tab. So what is this Feature Path Finder? It displays the features in the order in which the part is constructed. That means what and all features you have used to create the part, it will be displayed in the Feature Path Finder. Feature Library. It displays a list of documents you can place as features. Family of Parts. A family of parts is a collection of similar parts in different sizes or with slightly different detailing features. This tab creates or edits the family table members. So now let us come to constraints. Constraining sketches is an important step in the design process. Many features may be changed as the design evolves. Making sure the master sketch changes in a predictable manner is critical. Constraints are a combination of geometric, that is relationships like parallel, vertical, concentric, tangent, etc. and dimensional lengths. These geometric relationships we have already learned in the previous session. How it does parallel, it makes two lines parallel, vertical makes any one line vertical to the other or horizontal for that matter, and then concentric makes two circles are all concentric, means having those two circles or arcs will become, will be having the same center. Then tangent. Any circle you have drawn and tangent to that you have to draw a line that can also be done, and the dimension lengths. It's a combination of geometric and dimension lengths. See, let us see again here. Means I am not going to tell you that is connect, which connects two lines together. Concentric, horizontal, collinear, parallel, perpendicular, lock, rigid lock, that means tangent, equal, equal means makes two lines equal, symmetric, around the axis two objects will be symmetric to each other too, and then like this. Okay, these draw items may be changed by editing lengths, angles, diameter, radius, etc. When items are connected, changing one item may cause another entity to change in an unexpected or unwanted manner. That means if you don't have the constraints and if you are changing, say for example 3, 4, there is a rectangle. One side if you make around 80 mm, then the other side 20, and the opposite side if it is made too lengthy, doesn't look, see the diagram will go from one place to the another, means you will not find and you will be confused what to do next. So that is the reason these constraints are very much needed, very much necessary, which make the drawing precise and easily accurate. You can easily make the drawing accurate without putting more effort. Placing constraints on a 2D sketch helps you to ensure engineering intent. Now, geometric constraint symbols. The symbol you use to create a perfectly horizontal line is an example of a geometric constraint symbol. These symbols are visual clues that show you alignments, perpendicularities, tangencies, and so on. These constraints help you capture the design intent by creating constraints where they are recognized. Inventor displays the governing geometric rules as models are built. Continuation. When a geometric constraint symbol is displayed, the constraint is formed automatically when you pick with the left mouse button to form geometry. Means when the geometric constraint symbol it will be displayed, as soon as it is displayed or clicked, the constraint is formed automatically when you pick with the left mouse button. Just select the geometry and click the constraint. It will automatically left click on the first click on the whatever line you have to make perpendicular to that. Click that line and click on the constraint with the left mouse button. It will automatically be done very easily. If you want to prevent constraints from forming, hold down the control key while you are creating an individual sketch line or curve. That means if you want to prevent it from forming, you need to hold on control key, because as I told you, once you select the geometry line or something and click on that, it will automatically be updated, the constraint. So if you don't want it to happen because you want to give another 2 or 3 things together, then hold down the control key while you are creating an individual sketch, that is line or curve. Some of the most commonly used geometric constraint symbols will be shown down. Again, that is vertical, constrain 2 points on a line to an equal distance from the y-axis, ensuring that the line is perfectly vertical. Next, horizontal. Constrains 2 points on a line to an equal distance from the x-axis, ensuring that the line is perfectly horizontal. Parallel constrains 2 or more lines to be parallel to one another. Then perpendicular constrains the selected lines or curves to lie at the right angles. And coincident is constrains 2 points together or constrains 1 point to a curve. Now, draft environment toolbar. Drawing toolbar. This toolbar is extensively used in the draft environment for generating and creating drawing views. Next is relationship toolbars. This toolbar is used to apply relationships to the drawings you create in the draft environment. Here we are using drawing toolbar just for generating and creating drawing views, and relationship toolbar will be used to apply the relationships to the drawing which you have created in the draft environment. Now, additional design tools. Designing in Solid Edge is made easier by introducing the ribbon bar and edge bar. Designing is made easy by the ribbon bar and edge bar. The tools available in the ribbon bar and edge bar are different tools, different for different tools, and also in the different environments of Solid Edge. Either it might be the ribbon bar or the edge bar. It will be different and having different tools for different environments. For draft environment different, for part environment, for assembly environment, everything will be having different. Okay, now what is this ribbon bar? A ribbon bar enables you to switch back and forth while creating a model, an assembly or a drawing. So you can just go back and forth, either you are creating a model or assembly or a drawing. You can move back and forth. Now this part environment toolbars. What are the part environment toolbars? Okay. Update relationships. This button is selected to update both the dimensions in the part environment and the relationships in the assembly environment. Okay. You can update dimensions in part environment and relationships in the assembly environment. This is used. Features toolbar. The features toolbar consists of the modeling tools that are used to convert a sketch into a solid model. Sketch will be converted into a solid model. Now, what is the surfacing toolbar? Surfacing toolbar consists of modeling tools that are used to create surface models. It consists of modeling tools that are used to create surface models. This toolbar is available only when you are in part environment. When you are in part environment, then only it is available. That means surfacing toolbar can be used to making curves or on the say for example helical curves, etc. That is useful. Assembly environment toolbar. There are several toolbars that can be invoked in the assembly environment of Solid Edge. The assembly commands toolbar is used to create and manage assemblies. Now, let us come to the assessment. We have learnt in this session, the geometric relationships we have learnt. We have learnt about entity, profile, edge bar. Okay, all these things we have learnt over here. So, first one, let me tell you. What do you mean by an entity? And you have to give an example. So, an entity is nothing but an element of a geometry. Okay, an element of a geometry is called entity. For that, examples are nothing but line, arc, whatever you select, a point, a circle, etc. will be an entity. What does feature path finder display? Options are: it displays the features in the order in which the part is constructed, or it displays a list of documents you can place as features. So the answer is first one. It displays the features in the order in which the part is constructed. Second one is for feature path library. Second one is for feature path library. What does a surfacing toolbar consist of? See, surfacing toolbar consists of modeling tools that are used to create surface models. So, surfacing toolbar consists of modeling tools which are used to create the surface models. As I told you, and this surfacing toolbar is available only in the part modeling and part environment. You can give any curves only, these are the external surfacing you are doing for a drawing. Just externally, if you have to do any curving, helix curve, any curving to your drawing, that surfacing you will be able to do it by using the surfacing toolbar, but it is available only in the part environment. Okay, so this is about your assessment. Now that's all for today. Let us meet in the next session. Thank you.